Okay, so I'm going to be showing you how to set up your notebook in an organic chemistry lab. Now, there are many ways of doing this. This is something that I do personally. So to do this, we're going to start by drawing this reaction scheme. So that's just going to be the starting material along with the reagents and the solvent under the arrow, and you're going to draw the product on the other side. So if you're doing something like this is called a scheme. There are no mechanisms involved, just the starting material, the reagents you're going to use, and the expected product. The next thing is going to be setting up your table. So my table here has 6 columns, and it has a reagent column, molecular weight, millimoles, equivalents, density, and finally the grams or milliliters that I use for this reaction. So to start filling it in this case, I'm going to be using 1 gram of salicylaldehyde in my starting material. So if I set that to 1 gram, I'm going to find how many millimoles that correlates to by dividing 1 by 122.12, and then that's going to give me 8.19 millimoles. Next is a little bit of a shortcut. Instead of writing out salicylaldehyde or some other complicated molecule names, we could just put a number 1 right next to it. So the 1 right here correlates to the 1 in my table. And then I'm also going to do the same thing for 2-iodopropane, where that 2 correlates to the 2 in the table. The numbers that we'll get from the equivalent column should come from a procedure that you're following. The equivalents are important because this tells us the ratio of all the reagents that we're going to have in this reaction, so that if we want to run it on a larger scale or smaller scale, we can do so easily. So in this case, we're running this on, we would say, an 8 millimole scale. But if we want to run this on a 1 millimole, 10 millimole, or 30 millimole scale, as long as we keep the equivalents the same, everything should go as expected, to an extent. In this reaction scheme, we're going to set salicylaldehyde to 1 equivalent. That's because this is the main compound that we're performing a transformation on. So relative to salicylaldehyde, we will have 1.5 equivalents of 2-iodopropane, 1.5 equivalents of potassium carbonate, and 0.2 equivalents of cesium carbonate. There should be a subscript 2 right there, my bad. And then DMF is going to be a volume to millimole ratio. So for every millimole of salicylaldehyde I have, I'm going to have 2.5 milliliters of my solvent DMF. So from here, what I would do is multiply 8.19 times 1.5, and then that would give me 12.28 millimoles. So once I have that 12.28, I'm going to multiply that by the molecular weight of 2-iodopropane, divide that by 1,000, and then divide it again by the density of 1.703. And that's going to give me 1.22 milliliters. So I know that for this reaction I need to add 1.22 mils. I repeat the process with potassium carbonate, where I need 12.28 millimoles. So that's going to be 12.28 times the molecular weight of potassium carbonate, and then that's going to give me a value of 1.70 grams. And then same thing for cesium carbonate, right there. I then repeat this process with the other compounds, and that allows me to fill out the grams or milliliters used column. So just for clarification, I would take 8.19 and multiply that by 2.5 and then that is how I get approximately 20 milliliters of DMF. So then to fill out the theoretical yield, what I normally do is I write the weight of my product on the upper right. So this compound weighs 164.2, and I write it there just as a quick reference for future reactions. Our theoretical yield would be that 0.00819, and that is our millimoles just converted back into moles, and we'll multiply that by 164.20 to give us our theoretical yield of 1.345 grams. That just so happens to be coincidence. The last part of this is going to be filling in the procedure. Here you'll include in-depth description of the types of glassware that you're using, the workup procedures, TLC data, and any color changes that you see, so that if you or somebody else has to repeat this experiment, they'll have a heads up on what to expect. Alright, that about sums it up. If you guys have enjoyed this video, please leave a thumbs up, and I hope you enjoy running reactions.